So we're back for another thrilling episode of the battery-damaged Contax 137MA saga, and I really hope we're getting close to the end now. As a reminder for people who haven't been watching from the beginning, I got hold of a rather scruffy example of the camera which had clearly suffered a major battery leakage, but just how bad it was even surprised me, with the alkaline spreading its way to most parts of the camera. Adding insult to injury, there must have been some power left in the batteries as they leaked, because electrolysis had taken place on some components, such as switch contacts and wipers, with one half being more or less evaporated while the other half remained intact. I had to fabricate replacement parts for several switches and wipers along the way. Anyway, we finally got the camera partially working in the last episode, before the transfer switch broke, probably due to corroded parts inside. So I'll dig that out in a moment and figure out how I'm going to replace it. But I also wanted to investigate some other issues, mainly the state of the trace on VDD when the self-timer was counting down. I'd expect that trace to remain clean, but you can clearly see it getting all noisy every time the LED illuminates. Could that simply be because the extra load from the LED is drawing more power than a corroded via or track can handle? I'm very suspicious of some of the tracks that I can't get to on the shutter speed board, which also houses the voltage regulator. Additionally, I was reading VDD from IC4, which appears to get its supply via a route within IC2. There's no direct track to it, so once the camera is back running, I'll test the voltage right back at the regulator while the self-timer counts down. So I'll pop that transfer switch out and return in a minute. And there we have it. Next, to dissect it to see what actually failed inside. Okay, the failure of the switch was because one of its fixed contacts had fallen off, causing the moving contact to move so far that it wouldn't return again. I've got some suitable replacements on order, but I might just see if I can cobble it back together enough so I can carry on testing the camera for the time being. I do have a plan B and a plan C should I fail to fix this switch. Well, I did say that I was going to cobble it back together, and I'll get no awards for it being pretty, but there's the missing contact soldered back in place, and the switch working again. I wouldn't trust it for the long term, but it'll do for testing. Right, we're back in business. For the time being, I've left the exposure compensation LED disconnected, because it was on my list of things to check. When the PCBs are hanging loose like this, that LED is permanently powered and I didn't know whether it was causing any issues. I've got the oscilloscope hooked up with the blue on the output from the voltage regulator and yellow on pin 28 of IC1, which shows SPAD, whatever that is. So, power on, and we can see the usual trace on pin 28, with the voltage regulator showing 2.8 volts on the blue channel, which seems a tad higher than I'd expect, but only by 0.1 or 0.2 of a volt. And as before, the camera is waking itself up from sleep all the time. If I now press the shutter release button, the camera starts the self-timer, and we're back to the crazy noise every time the LED illuminates. I've frozen the screen during some of that noise, and it isn't pretty at all, but I have no idea where it's coming from. So I'll go away and do a bit more testing to see if I can find anything other than a failed chip that's causing our issues. Well, that bit of testing turned into a whole load of testing, and looking at the traces while the self-timer counts down revealed plenty of active pins on chips. Here we have VDD on the yellow trace and pin 16 of IC4 on the blue trace. The somewhat chaotic signal on pin 16 following the noise created by VDD, as you might expect. I then carried on going round in circles and finding nothing, until I flicked the shutter speed board while the camera was turned on, and we get that noise showing every time I flick the PCB. If I freeze that, we can see what it looks like, so I think there's still a flaky track somewhere where the flexible PCB joins to the shutter speed board, or possibly a bad via. I'd already rerouted another track that I found was high resistance, thinking that this will be the one, but it wasn't. So yet again I'll go away and do some more rerouting of tracks on this board to see if I can actually find something that makes a difference. Well, I've reinstalled the original power-on transistor instead of my temporary stand-in, and the ground from the camera chassis to this board was passing through some pretty corroded tracks, so I've wired the emitter of the power-on transistor directly to the chassis, also taking a wire to pin 17 on IC4 because it passed through a dodgy looking wire en route. But I'd tested all of these multiple times and they appeared to have continuity, albeit without any load on them. So I'll grab the oscilloscope again to see if that makes any difference. As before, I've got yellow hooked up to VDD and blue hooked up to pin 16 of IC4. And power on. So far so good, and if I flick the PCB the trace stays stable this time. But when I start the self-timer the usual chaos ensues. I'll let it run to make sure the shutter still fires, which it does, but clearly we haven't found the source of the problem yet. Next, I may as well reroute VSS and VDD to the chips, but I doubt that it will make any difference. And hands up anyone who thought that would fix the problem. Nope, I didn't think there would be many of you. I'm tempted to give up at this stage. My definite hunch is that one of the chips is damaged, probably IC2, which is the one that does all the clever stuff. So I'm going to change angle. I haven't successfully run the camera with the boards assembled, so I don't know how much is or isn't working. So I'll pop this lot back together and then have one last look before I throw in the towel. And as if by magic the whole thing has gone to pot again with those crazy voltage spikes as soon as I turn the power on. I'm going nowhere with this. Time to give up, I think. Some people just don't know when to give up. After that I turned my attention to the working camera. When I first got it, the shutter speed dial was stuck and I just assumed that it was firing at its flash sync speed, but once I'd got it open and moved the dial it was clear that it made no difference to the speed. In fact, looking at the shutter curtains they were both moving at the same time, so the second curtain magnet wasn't being activated. I'd already seen that the shutter speed LEDs were indicating the correct speed, so I got the multimeter out and checked the resistance across the magnet, and it's reading as open circuit. So I'll strip the shutter button plate off in order to get at the magnet, in the hopes that it's simply a broken wire or something like that. I don't really want to do a rewind on that thing just to test the camera a bit. And kind of annoying but predictable, the shutter magnet has failed on this spare camera. Ideally I want to check that the whole camera is operating correctly before I base any of my expected test results on it. So I'll dissect this and decide what to do in a moment. So there's the winding removed from the core. What you always want is to find the break close to the outside of the coil, so you can just remove a couple of turns and solder the connecting wires back in place. But that's rarely the case, and usually the break is right in the middle. So I may as well unwind this and then decide whether or not to rewind it in a bit. And there's the break, just a few turns away from the inner end. The wire is 0.05mm in diameter and the finest I've got in stock is 0.08mm, so I'm half inclined to rewind it by reusing the existing wire, just leaving out those few turns where it was broken. And if you were expecting some fancy bit of kit for doing the rewinding, you obviously didn't see my video where I rewound the magneto from a BSA charging set. I'll put a link to that one down in the description, and I'll carry on with this one off camera because I do need to concentrate a little while I'm doing this. The usual story prevails, ugly but functional. I'll get that installed back into the core and reassembled onto the camera. And then take the camera apart again because the magnet wasn't holding the curtain. I was hoping that I wouldn't need to readjust the second curtain start plate, but clearly I did need to, and now, having adjusted it, I can release the shutter whilst applying 1.8 volts to the magnet, and the second curtain is held, until I remove the voltage and the second curtain is released. Now to reassemble it again. Right, that's better this time. If I fire the shutter on 1 second, that's working, and half a second, and quarter of a second, all good. So with a bit of luck, the spare camera is now fixed. I can't say the same for the project camera though. So back to the project camera. After I last assembled it and the power supply went all spiky again, I seem to have lost some functionality. The shutter speed LEDs had previously been flickering, but now they appear to be dead completely. This could be because those chip-busting spikes have done their worst, or another track has broken, or that the main chip, which is the one that controls those LEDs, is gradually dying. I can still fire the shutter, and the self-timer still works, but other than that the camera is pretty useless. My thought now is to pluck out the voltage regulator again and test it on the breadboard, this time with a load, in case that is when it gives those scary spikes. Somehow I doubt it. I still think it's somewhere else in the circuit, but I don't know what. And here's the voltage regulator connected up with a 47 ohm resistor across the output, which will give it a 55 milliamp load, and it's maintaining its 2.6 volts. Whereas if I swap that to a 22 ohm resistor, giving it a load of 118 milliamps, the output drops to 2.16 volts and falling, which could potentially cause one of the chips to reset repeatedly if the camera is pulling too much current somewhere. I guess the next thing to do is to measure the load in the camera itself. Well, that is all fairly unconclusive. When the camera is sitting idle, the load hovers at around 6 milliamps, falling to under 2 when the camera goes to sleep. And when I trigger the self-timer, my multimeter is a bit slow responding, but I haven't seen a figure higher than 14 milliamps while the self-timer counts down, which is of course where those undulations in the voltage were showing up before. However, it is all dancing around rather a lot. Somehow I'd expect it to look a bit more stable, so I'll grab the oscilloscope and add that into the mix. And as always, this camera makes no sense at all. Firstly, when the camera goes to sleep, it now stays asleep until I half press the shutter button to wake it up. Secondly, we'd seen that the voltage regulator was giving the correct voltage of 2.6 volts when I tested it on the breadboard. Well, it's still on the breadboard, but now I'm seeing 2.72 volts, so where has that extra 0.12 of a volt come from? And thirdly, now, when I start the self-timer, the trace is all nice and clean like it should be. So what's the difference? Why has it changed when all I've done is remote mount the voltage regulator and put an ammeter in circuit? And just for a little more confusion, I've now bypassed the ammeter and the noise is back when the self-timer counts down. This thing is driving me bonkers. After that I removed a few capacitors to check they hadn't failed. I didn't expect to find anything wrong and I wasn't disappointed. So I gave up and went to bed. But I got thinking, why is there a digital signal between IC1 and IC2 and none of the other chips have a signal like that? IC1 just has all the exposure adjustment pots and the silicon photodiodes going into it. Unless that chip converts the light value into a digital output for IC2 to process. So back to my working example, and lo and behold, as I move the torch, the width of the trace on pin 27 changes, and under certain circumstances the trace has disappeared altogether, making it look just like my project camera. And a bit more testing later, I've adjusted the film speed to a faster setting, and now when I bring the torch in, the trace disappears when we get too much light. So, is something on the supply to the photodiode, or the diode itself on my project camera, sending this trace out of limits? When I went back to the project camera, the voltage was all unstable again, regardless of whether it was counting down the self-timer or not. So I spent ages going round in circles and bashing my head against a brick wall. When the voltage being supplied to the chips is unstable like this, there's no point attempting to test anything else because it simply isn't going to work correctly. I removed this variable resistor block to check some of the components hidden beneath it, and capacitor C10 was a fair way off its specified 0.22 microfarads, reading at 0.34 microfarads. Unlikely to cause the issue, but sometimes my component tester doesn't tell the whole story when checking capacitors. So I popped in a replacement legged capacitor, which makes no difference at all, so I'll swap back and continue searching. The last time this camera had a stable voltage was when I had the ammeter in series with the output from the voltage regulator. And all the ammeter does is place a small resistor in the circuit and measure the voltage drop across that resistor to calculate the current. It will be a very low resistance and will have a negligible effect on the voltage getting to the camera. So I've rerouted the voltage regulator to make its output pass through the lowest value resistor I could find, which is 10 ohms. And magically we now have a nice stable voltage, albeit reading 2.8 volts rather than the 2.6 that I'd expect to see. This isn't a fix, but it is a temporary bodge that allows me to test other things and maybe find the overall issue by going down a different route. On top of that, we now have a signal on track LAD coming from pin 27 on IC1, so that's another plus. However, the camera does keep waking itself up again, so it's not all good yet. I'll go away and tidy up my temporary resistor so there's less chance of it shorting out, and then take some more measurements. Okay, I've done a load more meddling since that last clip, and I've kind of got nowhere. The light meter is responding to light, but it seems a bit flaky at times. There's no signal on track LAD if I don't have the film speed selected, so I've got a bit of silver foil clipped to the variable resistor, probably at around 400 ISO I think. I've also added some wires to the shutter speed selector board so I can simulate the wiper contacts. If I ground the blue wire I should be getting half a second, and if I fire the shutter the second curtain magnet is getting power briefly, but it's not holding the curtain back. I tested this several episodes ago and it was working, so I'll desolder it and test it again. Actually, before I filmed that last clip, the second curtain magnet was getting its half-second pulse, but it wasn't holding the curtain, and as soon as the video camera started rolling, any indication that the shutter timer was working simply disappeared. I also got thinking about the power supply to the magnet. The control signal comes out of pin 51 on IC2 to pin 15 on IC4. And then IC4 does the heavy lifting, sending the power out of pin 10 to the magnet. And IC4 has VDD going into it in two places. Possibly one of these is switched directly to pin 10 to provide the power for the magnet. And continuing that thought, I've currently got a 10 ohm resistor in the VDD line, which could potentially reduce the voltage enough when the magnet is powered that it no longer has the strength to hold the shutter back. Anyway, I'll hold that thought for the moment. Additionally, I was thinking about the camera waking itself up all the time, so I popped the scope with blue on the base of the power on transistor and yellow on the output from pin 39 on IC2, which should control the power on transistor. When the camera goes to sleep, yellow goes low, but the base of the transistor remains floating at around 0.6 of a volt. If we look at the circuit diagram for this section, when the power is removed from this track, the base of the transistor, which is on the other side of this 2K resistor, should be grounded out by this 8K resistor. So possibly the ground track has failed, or one of those screen printing resistors has failed, or something else entirely. Anyway, I'll do a little more testing and report back in a minute. And as always, that got me nowhere. I cut the ground track to the 8K resistor to eliminate it and soldered in a temporary replacement, but the base of the transistor still isn't going to ground when the camera goes to sleep. I think I need to access the power on transistor on the working copy to see how it behaves before I get too carried away with this. While I'm thinking about it, I've unsoldered the wires to the second curtain magnet and connected the bench power supply set to 1.8 volts. And if I release the shutter, the magnet isn't holding the second curtain. In fact, the magnet is reading very little resistance, so although I tested this as working a few episodes ago, it's now conked out. I'm guessing, knowing this camera's history, that the windings will be badly corroded, so using the same wire for the rewind might not be an option. So I'll get some wire ordered and rewind this one. Take a load more measurements from the working camera and do some more thinking. But for now, to avoid the risk of this video getting stuck in an infinite loop, I'll end it here. I might do a couple of non-repair videos before I return to this project, just for a bit of variety, but this camera will return sooner or later. If you've enjoyed watching, please like the video and maybe even subscribe to the channel, not forgetting to click on the bell icon so you get notifications when a new video is released. That's it for now, so thanks for watching, and I'll see you in a future video.